for the balance of the program, is this too loud? Okay. For the balance of the program, I really want to kind of dive into the nuts and bolts on the different characteristics and the different listings. So we talked about declared, no requirement, state or federal, that requires us to test our waste. We're liable to know the characteristics. I don't know them. Yeah, you might want to test your waste. Let me think. I generate 5 gallons of paint. I'm going to test it? Yeah, probably not. From a cost-benefit perspective, it's not going to happen. Although, if I produce 14 tons quarterly, I'm probably going to test my waste. And when I test my waste, there is something that's in the standard, Title 22, Appendix 10, that says that you have an 80% degree of assurance that 80% of the time that this waste that you regularly produce using the same process is or is not a hazardous waste. And you can determine that using a calculation called student T analysis. So what if I test that 14 tons quarterly every time I send it out? And every time I test for it, it's hazardous, and then it's hazardous, and then well, it sounds like you have a hazardous waste. Every so often, it's not. It sounds like you have a hazardous waste. And there's a calculation that you can follow in Title 22. It's called the student T analysis, where the state has determined that you have to have an 80% degree of assurance that it is or is not, and that I can use as a baseline. But to establish that, I may have to take a minimum of 4 samples. Could be 6, 10, 12, 14, 18. Depends on how close I get to that regulatory threshold. You know what I just said, but I didn't say? There is, on occasion, I produce a waste. It's not hazardous. And then every so often, we're talking a blue moon, every 3 or 4 years, I have this excursion with a contaminant that is either borderline or it's above the regulatory threshold that makes it a hazardous waste. And I have not been managing it as a hazardous waste. And I disposed of it not as a hazardous waste. Well, then we have to look at, okay, well, what's the protocol for sampling? Is it a representative sample? Is it a biased sample? Is the process that produces the waste established, and is it the same? Or do you have different types of materials that you're using in a process that influence the characteristics? You ready? It's gray. It's not black, it's not white. It's gray. So, but if I test for my waste, I can determine the characteristics. And we'll talk about that here in a few. Listed wastes. I produce carbon disulfide. I manufacture it. Or carbon sulfide. And there's a K-listed stream for manufacturing carbon sulfide. And I use 14 different chemicals, this process, and I make carbon sulfide. That's what I make. And it says that any still bottoms that are produced from the manufacturing of carbon sulfide is listed waste. It's K0, I don't know, 13. Oh, okay. The waste that I produce from the still bottom tanks to make carbon sulfide is a federal listed RCRA waste. It does not matter if it's really toxic, sort of toxic, kind of toxic, or not toxic. Doesn't matter. It's listed. It's captured. That's a RCRA waste. I can change my process, and I can make it really not toxic at all. Great. Still listed, still a hazardous waste. That's a federal listed waste. I can delist it, but that requires concurrence from the federal US EPA agency. Question? I'm sorry, yeah, you can. Yeah, and it does happen on occasion. Not often, but it does happen. Yeah. And sometimes when I test out, it's for the industry. Generally, it's for a specific process within an industry. Yep. Yeah. That's called delisting. That process federally is called delisting. I had someone come up on the break besides our someone's on the break, And I did not talk about special wastes. Special wastes came up on a slide, and I blew by it. I guess I had a brain fart. But a special waste is a waste that the federal government says, hey, this waste, we do not consider it hazardous wastes, regardless of its characteristics or its tests. Baghouse, fly ash are perfect examples. So if you have baghouse or fly ash waste, federally under RCRA, off the radar. So if you're located in New Mexico, Arizona, or Nevada, not a hazardous waste. California says, yeah, you know, there may be issues with those waste streams. So, tell you what we'll do. We're going to allow industry the ability to petition the state of California, DTSC, and ask for regulatory relief from the regulations, and we'll classify that after we've concurred, evaluated, and established that that material that's excluded federally will allow you to take it to a landfill in California without a manifest, without a registered hauler, without counting against your generator status as a special waste. That requires concurrence from the state of California. I can determine if my waste is hazardous, no biggie. But for me to think that it's a special waste, that means that I have petitioned, wrote, characterized, qualified, and received concurrence that, yep, it's special waste. That is the same process as federally delisting. Same process. But the delisting federal, special waste classification state. And then the mixture rule. And I'm not going to kick this around too long, but it goes like this. If I've got a hazardous waste that's corrosive or ignitable, let's go corrosive. It's an acid, sulfuric acid, H2SO4, battery acid, rhodo, liquid fire. I use it in industry. And then I put it in a drum or a tank or a portable tank. And if I mix enough water with it, or sodium hydroxide, I'll neutralize it, or I raise the pH, now the pH is 4. And I do that, and then I dispose of that as non-hazardous. Because under the mixture rule, under RCRA, I can do that. Now that has nothing to do with us in this room. Because A, we call that treatment in California, and B, you'd have to get a permit to do that. Then there's some exceptions called the laboratory rule that I'm not going to cover. But for the most part, that mixture rule says that if you have a characteristic waste mixed with a solid waste and it loses its characteristic, no longer hazardous waste. That's the mixture rule. The other part of the mixture rule is if I have a listed waste, federally listed RCRA waste, FKPU, and you mix it with a solid waste, if you mix it with a solid waste, the listing still applies. So then when I go to dispose of my solid waste, it is now a federal listed hazardous waste. I just got more of it. That's the mixture rule. And you wouldn't do that in California. Is that clear as mud? Yeah. Derived from, yeah. The derived from says that if I have a waste that's listed federally under RCRA and I send it to a household hazardous waste facility and they take that waste and they combine it and commingle it and do something with it and then they treat it. But it's a listed waste not because of a characteristic, just because it's listed. I got to explain that. Some listed wastes are listed because they exhibit a characteristic. Some listed wastes are listed because they want to list them, and they may not exhibit a characteristic. If I have a listed waste that's listed because it's toxic, there is not a characteristic that I can use to determine if it truly exhibits the characteristic or not, that listed waste remains listed forever. If I have a listed waste that's listed because it's ignitable, and it gets blended with something else, and it loses its ignitability characteristic, and the only reason and the sole purpose why it was listed was because it was ignitable, and I list it because of ignitability, and I mix it with some other waste, and it loses that characteristic, which is the only characteristic why it was listed, then that listed waste loses its listing. Now, I just described one of the 39 F codes. So let's forget I said that the last 2 minutes. Okay? Right. The best thing I can tell you is, if it's federally listed, it's always listed. How's that? That you can remember, right? If it's an FKP or U and I mix it with something else, it's always listed. It's managed as a hazardous waste, has a federal land disposal restriction standard that applies to it as well. How's that? Now, I'm lying to you 0.001% of the time, but it probably doesn't apply to anybody in here. I told you it was simple. Okay, all right. All right, so that's the mixture rule. So, my waste is not excluded. Okay, my waste is not excluded. Maybe it is. Household hazardous waste, federally excluded. Mining waste, federally excluded. Lead acid batteries, federally excluded. They're not a hazardous waste federally. Oh, okay. So I exclude them federally. They may not be excluded in California. And the ones that I just picked on, they're not excluded in California. They are a hazardous waste in California. So when I go to figure out whether a waste is a hazardous waste, if it's excluded federally, not a hazardous waste, but we consider it a California hazardous waste, we call that waste a non-RCRA hazardous waste. I'm going to say the same thing differently. Certain wastes appear to be a federal waste. That makes them RCRA. But some wastes that exhibit a RCRA characteristic may be excluded, so you would never give it a RCRA hazardous waste code because it's not a RCRA hazardous waste. There are certain wastes that are hazardous wastes because California does not exclude them, but they're excluded federally. So when I go to classify my wastes, the federal code under RCRA would never apply to that waste stream. Perfect example. What are the components of a lead acid battery? Sulfuric acid and lead. So it has a code for being corrosive, and the characteristic code for corrosive is D002. And then the code for lead is D008. So I have a waste that's both corrosive and it has lead. It's a hazardous waste. Those are the codes. And it exhibits those characteristics. But it's excluded from RCRA. So even though those codes you think might apply, they don't, because lead acid batteries are excluded from RCRA because the battery industry lobbied significantly in '76 from RCRA, and they excluded it from the definition. It's actually listed as one of the many exclusions. California says, no problem. We consider it a non-RCRA hazardous waste. And then we go further to say, well, as a matter of fact, if you recycle them, then those materials that you recycle, if you follow these set of regulations, you can exclude that from being managed as a hazardous waste if they're recycled. All right. So my waste not excluded. Not state, not federal. We don't exclude a lot of things in California. Certain secondary materials are excluded. So if it's not excluded, if your waste is not excluded by definition, is it listed? Look at the federal listing under RCRA. And there's 4 categories. PU, FK. is your waste a listed chemical on the P and the U list, or is it a process waste that comes from a waste stream produced under the F definition or the K definition? And those are specific source and non-specific sources. Producing a waste. Let me say the same differently. P and U target chemicals. There's about 1,200 of them. Is it one of those 1,200? Nope. Yeah, it is. Oh, okay. If it's one of those 1,200, did you use it? Yeah, it's used. It's spent. I've used it in a process. Oh, okay. It's not a P or a U, because those chemicals are chemicals that were never used. Because if I used it, off the radar, the P and the U's only apply to chemicals that I purchased, but I never used them. So if it's a process that produces the waste, that's F or K. Well, I bought it, I'm going to use it, but I never used it in that process. Oh, okay. It may be a hazardous waste, but not on the F and the K. Those are only waste streams that are coming from a process where it's been used. It's been subjected to some form of use on site before you generated that waste. But that listing, it's not listed. Oh, okay. Then, if it's not listed, most chemicals that are considered hazardous waste in California aren't listed federally. A lot of them are, most aren't. About 94 to 96% aren't listed. They're a characteristic, they're a California non-RCRA. Most aren't. What captures us, California, for materials that end up being a hazardous waste is because they exhibit one of 4 characteristics. And those 4 characteristics are ignitable, corrosive, reactive, and toxic. And to make matters a little bit more enlightening, we have 4 characteristics federally, we have 4 characteristics in the state of California, and they're the same 4 characteristics. And 2 of them are the same definition. 2 of them, they're different. But we have 4 characteristics, same 4 characteristics. 2 are defined the same, and 2 of them, there's a stark difference. I'm going to dissect that in a couple minutes. To make my determination, apply knowledge. Well, I use sulfuric acid at 0.05%. That's listed with some sodium bicarbonate in a solution. I add that to 98% water, and I use that as a cleaning agent, and then I dispose of it. I know the pH happens to be about 6.5. It doesn't kill fish. I don't use it as an etchant. It's not that toxic. Oh, okay, that's generator knowledge. I've determined that I can flush it down the toilet. You can do that. Or, turns out that my sulfuric acid has a 4 molar concentration. The pH is around 1.3. And after I use it, it's about 1.3, and it's contaminated with certain metals. Oh, okay. I don't have to test it. I know it's a hazardous waste. We're good to go. That's applying knowledge. I modify that, and I make it a 0.5 molar solution, and it's about 3% sulfuric acid. I don't know what the pH is. Okay, then you test it. All over the board. You are responsible for your decision, but we don't tell you what that is. Now, we're likely to challenge you, though, right? Because it's more, the way the regulations are written, they place the regulatory burden on the industry to validate or produce sufficient evidence that convinces us or the enforcement agency not subject to regulation. I'm not certain. So I haven't determined that. I haven't calculated that. I'm not certain what. Sounds like you don't have knowledge. And if I don't have knowledge, it means that I'm at risk of being challenged for my decisions. All right. And then we talk about some exemptions. There's state exemptions, there's federal exemptions. These are listed in 66-261.4. There's exceptions to the rules. I do not want to talk about the exceptions. They exist. They exist in the regulations. Some of them exist in the statute. We call those excluded recyclable materials. But those are wastes, but they're excluded or exempted from some of the requirements. Not all of them, some of them. Okay? Federal, RCRA, state, non-RCRA. Federal RCRA, state, non-RCRA. We're good to go? State, federal, RCRA, non-RCRA. Right? This slide is the one that I'm going to dissect. This is your class. This is what we're going to talk about for the remaining hour. This is it. on this schematic on the board, you have two separate, independent, combined programs. The federal's on the left, the state's on the right. The federal program says to be a hazardous waste, it's listed or it's characteristic. There's 4 different listed wastes. There are 4 different characteristic wastes federally. And if it's any of those 8, that is a RCRA waste. California says, I like the idea. Let's do something similar. That's what they did. So on the right side of the slide, California came up with a list and said, we think these are hazardous wastes. They may not be, but they probably are. We're going to call them presumptive. We presume they are. You know what presumptive means? Ready? Maybe. Yeah, maybe. Maybe not. But now the burden to prove that they're not rests with the responsible party, the generator. So the presumptive wastes, we have 2 types. Ready? We have a list of chemicals, and if that chemical is in the waste, it's presumed hazardous. It might not be. It might be. But if that chemical is in my waste, then it's considered to be a hazardous waste. No discretion given on the concentration. 100%, 50%, 1%, 0.1%, 0.0001%, 0.00, 1 part per quintillion hazardous waste. That's the presumptive list by chemical. And then they say, yeah, before you go there, let's list common names of waste. These wastes are generally hazardous wastes. And so we have things like chemical waste, toilet waste, laboratory waste, toilet bowl cleaning wastes, spent solvents, used oil, antifreeze. There's a list of about 100 common names of wastes. And commonly, California, it's been determined these are generally hazardous. They're almost always hazardous. Then that's the common name. Those are presumptive. You may have a waste that's by common name not a hazardous waste, but you have to be fairly sure that it's not to subject it to hazardous waste regulations, because the presumption is it is. So you have to be pretty certain that it's not. Now, that presumptive list, we have it by common name, we have it by chemical. Those are presumed hazardous. Turns out that if those presumptive wastes are tested and they do not exhibit a California characteristic of a hazardous waste, of which there's 4 characteristics in California, then that presumptive waste is not a hazardous waste, even though it's listed as a presumptive waste in California. Right? I'm going to try this one more time. I'm going to try this a little differently. I'm going to approach it a little differently. Ready? Here we go. Ready? The presumptive waste list means nothing. Did you get that? You know why? Because if a waste that I produce on site exhibits a hazardous waste characteristic, that's a hazardous waste. Check this out. I produce a waste on site that doesn't have one of the 785 chemicals in it, and it doesn't come from the common list of names of chemicals or streams or processes that make a waste in California. But it is a characteristic waste. So it's not on the list, but it exhibits a characteristic. That's a hazardous waste. It is on the list, and it does not exhibit a hazardous waste characteristic. That's not a hazardous waste. I'm going to say the same thing a third way. It means nothing. You with me? People get wrapped around the axle. They start looking at that list and they go, oh, okay, it's a hazardous waste because that chemical's in there. Oh, okay. Somebody in their infinite wisdom 39 years ago said, yeah, it looks good. That's what they did. That's the list. We're good? We don't hang our hat on it. Okay, all right. Then California says, hey, if we have a waste that's ignitable, that makes it a hazardous waste in California. Turns out that if you have a waste that's ignitable in California, we adopted the same definition federally. So it turns out that the federal definition of ignitable waste and the state definition of ignitable waste, they're the same definition. So if it's state, it's federal. If it's federal, it's state. Congratulations. If it's both, you have a RCRA hazardous waste. How you manage it, how you dispose of it is driven by the federal standard. And when you dispose of it and you send it to a facility and they treat it, the treatment standard is driven by the waste code, which is D001. And the definition that we have in California is exactly the same definition that exists federally. So if it's not excluded from the federal definition of being ignitable, like household hazardous waste are, they never carry federal code. But if it's ignitable, it's both. If it's both, it's a RCRA waste. It's not both. Well, ignitable is not a good example, because if it's corrosive, we have a difference in our definition, California and federal. There's a difference that exists. So if it's a federal hazardous waste under ignitability, it's also state. For corrosive, we could have a waste that's considered to be corrosive in California, not considered to be corrosive federally. Well, that's a non-RCRA hazardous waste. That's not a RCRA hazardous waste. Well, congratulations. That's a hazardous waste. And it doesn't matter, because in California, if it looks like a duck, quacks like a duck, reproduces like a duck, that's probably a duck. And how you manage it, mark it, label it, store it, accumulate it, how long you can keep it, it's the same. It's just that one has a federal code and the other doesn't. It's all the same duck. We manage it the same way. Now, you don't dispose of it the same way, but it's all the same thing. All right, so here you go. The federal, so what I'm doing, I'm going to dissect this. As I dissect it, I have a tendency for people to lose track of the diagram. Here's the diagram. I'm going to talk about the federal listed wastes right now. Then I'm going to talk about the presumptive wastes, which I already have done, but I'll do it again briefly. And then I'm going to spend the balance of the program talking about characteristic wastes. Then we're done. That's what makes a waste hazardous. It's either listed or characteristic. Now, California, when we came up with the universal wastes, by definition, we came up with our own select group of listings in California. And these are mercury. So if I got something that contains mercury, an automotive switch, a light ballast, a fluorescent tube, yeah, we're gonna list these things. So when you get rid of something that has mercury, California says, yeah, it doesn't matter how much mercury. We're not going to play the shell game. Is it above or below the T-clip wet test? Is it? Nope. We're going to list it. Hazardous waste. Done. Although, for fluorescent tubes, that's not listed. Those are universal wastes. And we don't care what the content of mercury is inside the fluorescent tube. All right. So this is what we're going to dissect. I'm going to dissect it. Federally listed, 4 categories. The F and the K, I've used them. I've used the materials. I've put them in a process. I extract the waste that's produced from the process. I'm going to get rid of it now. 2 categories. I'm going to specifically identify the chemical that I use, but I won't necessarily talk about the process that I use it in. Those are called non-specific processes, non-specific listed chemicals. For example, the F codes, we call them non-specific source waste. If I use ethyl acetate, methyl alcohol, benzene, ether, ethyl acetate in a process for cleaning something, and I don't care what you clean, I use it for a cleaning, a degreasing compound, and I can degrease lots of things using certain types of solvents. I don't care what you're cleaning. I'm going to target the chemical you used. Those are the F codes. Those are the F codes. Don't care how you use it. You use that chemical. F codes. Flip over the same coin. Those are the K codes. I do not care what chemicals you put into the process. I'm going to target the process. We call those specific source codes. It's the specific process that produces the waste is listed. We don't care whether or not you use 14 chemicals, 2 chemicals, whether it's toxic, really toxic, not toxic. Is everybody with me? By the way, these lists came out and they were generated in '74. Do you know how much we've evolved as a country since 1974? Very archaic. There's a lot of things that we do today aren't listed. There's a lot of things that we did back then that we don't do them anymore. Very archaic. Considered and has been proposed to revise this for years, federally. And we've tweaked it. We've added a couple more. But what we came up with in '74, when I was in high school, we're still living with. Not a big difference. Not a big difference. Okay? Switch gears. The discarded. I'm going to get rid of it. I bought it. I didn't use it. I want to get rid of it. Okay, I'm going to get rid of it. I didn't use it, but the sole active constituent, or the only chemical in this container, is this chemical, and it's on a list. If it's on a P list, it's considered acutely hazardous, and if it's on the U list, it's considered toxic, just not as toxic as the chemicals that are on the P list. Those have not been used. Well, I bought some of these chemicals, and I used some of them in a process, and I put the waste that was spent into a drum. And then I took the chemicals that I didn't use, and I combined them in the same drum. So now I've got waste produced from 2 different sources. One's been used and one hasn't. Well, the ones that were not used will have a P code or a U code, and they apply to that drum. The ones that were used, they don't have the P code or the U code, but since I commingled them, you've just produced more waste. Because once it's listed as P or U, always listed. That's the mixture rule. So to know if it's P, U, K, or F, when I fill out a profile as a generator does, it is imperative that I know the process from which the waste is produced. I got one for you. Indosulfan, P027. So indosulfan, pesticide. So I have indosulfan. I'm a chemical manufacturer, and I sell it to Pat Ledesma. Pat Ledesma is the world-renowned farmer for citrus fruit in the state of California. Pat buys my indosulfan. He is going to apply that to his crop. And when he applies it to his crop, he kills the pest, grows a lot of fruit, gets rich, buys an airplane, comes up and takes me fishing in Montana once every year. I like Pat. Pat calls me up and says, you know, hey, Jer, I got a little bit of an issue here. I got some dirt that's contaminated. It's got indosulfan in it. How do I dispose of it? Pat, not a problem. I know somebody a lot smarter than me, and they can figure this out. So I call and say, hey, how much indosulfan does it take for my waste to be hazardous waste in California? Federally, because indosulfan is a federal P-listed acutely hazardous waste. And the answer is, there's no threshold, right? So I said, well, but I got indosulfan in it. Oh, okay. Did the dirt that Pat put in a drum that he wants to get rid of, where'd it come from? It's out in the orchard. Oh, okay. So that dirt came from the orchard. So that indosulfan was used. That was applied. That was used. So that doesn't have the P code. That doesn't have the P code. But if Pat says, hey, Jared, the indosulfan came from immediately adjacent to where I stored it in a shed on site, it's either spill residues thereof or it was spillage prior to its use. Oh, okay. That indosulfan code for P027, that applies to my waste because that is a spill residue thereof of an acutely hazardous material prior to use, and it was the sole active constituent, and I used that material when I disposed of it. I used that material prior to application. Now, the indosulfan was in a carrier solvent, so it was dissolved in acetone. And I used a little bit of sodium lauryl sulfate as a surfactant that was a preservative. So it was a mixture. but the sole active constituent that I used it for was endosulfan. Oh, okay. That P code still applies because the sole active constituent was endosulfan. So for me to figure out does the P code apply or doesn't apply, you have to know the source that the endosulfan was derived from. And if I don't know it, I'd never know. Yeah. No, it's not an acutely hazardous P-listed RCRA waste. That's correct. That's correct. If I dig up the dirt and I remove that and I care to relinquish it and discard the dirt off-site, then it becomes a waste. But if it's just sitting there, not a waste. Right. That's right. You're spot on. I'm not going to dig up the dirt. Yep. Yeah. Are we good? Does it make sense? We're good. We're good? Rick, check this out. My endosulfan that's P-listed is at 0.01 parts per billion. 0.01 parts per million. My endosulfan from the orchard is at 1,345 parts per million. So it's a degree of about 100,000 more concentrated the dirt from the ground. That dirt that's really high concentrations, not listed. The dirt that has 0.01 part per billion, that is listed because that's from a spill residue thereof. Right? You know what I just did? I just tried to convince you, do not apply logic to the regulations. That's what I tried to do. All right, so we're good? That's it. That's it. We're good? Because we're done with listed waste federally. We're done. So if you don't understand listed wastes, I haven't done you justice. PCE, okay, is PCE, is there a T-clip for PCE? Is there a T-clip for? It's listed, okay. But is there for TCE, PC. Is there, for pentachloroethylene, is there a T-clip value for it? No, okay, all right. Okay, so I have it's listed. Is the process, is it K? Or is it U? It's U. It's U. All right, so I got a dry cleaner. So Pat asked me, run through this scenario for PCE. So I have a chemical, acronym PCE, and I take that and I use it in the dry cleaning process to actually clean a degreasing solvent to remove greases and stains in dry cleaning. So I buy it. I use it. I buy it. It's listed. It's a U-listed chemical. I think it's U-listed. Or is it P? Yeah. Okay, so I take that material, I buy it in bulk commodities, and I introduce it into my process, but I blend it with other things. I use it at 3% concentration, but I buy it at 100%. So I blend it with other materials, water, in the dry cleaning operation. That material that I buy, where it's just PCE, is U-listed. And if I decide to change the process, then I get rid of it, I don't use it anymore, that's U-listed, that's listed, that's a RCRA hazardous waste. And I didn't use it. Because if I did use it, it can't be U. Then I put it into the process and I use it for a dry cleaning solvent to remove degrease from materials that I clean. When I do that, I produce a waste, because I intend to get rid of it. We're going to call that discard. So I'm going to discard this material I no longer want. That's a waste. Now that's coming from the dry cleaning operation, and it's used in a chlorinated solvent, PCE, in the dry cleaning operation, and that chemical is listed as FOO, I think it's 4 or 5. Yes, okay. So it's listed as F004, F005. And it says that if you use this chemical in a process greater than 10% concentration prior to use, and you produce a waste derived from using PCE, which is a chlorinated solvent, and you collect the waste, that is a F-listed waste stream because I use that solvent. No longer is it U because you've used it. It's a spent process. And that chemical is identified in the F codes. So all of a sudden, the same material that I get rid of after use has an F listing associated with it, makes it a federal RCRA waste. Okay, and I got a question too. Okay. I want to see an honest raise of hands that you're going, what? Because to be honest with you, I'm thinking what? I just told you and I'm thinking what? I'm thinking it. How many people thinking it? Right? I'm sorry. And I will, when we're done, stay here till the cows come home. If you come up, and I'll go through it a third time and a fourth time. I'm not a smart guy. I really am not. It took me years. I mean years. I'm kind of a smart guy. I mean, I went to Berkeley, but I'm not that smart. It took me years. And once I got it, I got it. It took me years. So do not feel dumb. Is that fair? Okay, all right. No, Pat. Okay, it's in your dirt. A drum of waste from virgin material. Okay, so Pat says, I have contaminated dirt, soil, from this chlorinated solvent, PCE, that's coming from a dry cleaner. You want it alone. Pat took and sold his private Learjet, and he bought 4 more dry cleaners. And when he bought the 4 dry cleaners, they required a phase 2 assessment. So they did some drilling. And they actually tested the soil, and they found PCE, a chlorinated solvent, under the ground of one of the buildings when they drilled. I don't know if it came from a dry cleaner. Oh, okay. So check this out. Is it from a spill residue thereof, or from virgin material that was stored there historically? That's the peak, that's the U code. Or is it from a process that was employed there 25, 30 years ago, where it came and it was spilled from a process after it was used? And the question is it a U code or is it a F code? And you have to know the process. I'm clueless. I have no idea. I just moved to California 6 months ago. I'm trying to figure out where the Nimitz is relative to 880 and 680 and the 280. I don't know. What? Generator knowledge. So I test for it. And I figure out how much is in the dirt. You still can't answer. And I can't answer your question, because I don't know the origin of it. I don't know if it was used or not used. And if it was used and it contaminated the ground, it may be F. It's not used, it was spilled, it might be U. I can have a high or low concentration from either of those 2 sources. My point is, to be listed, you have to know how it was used, or if it was not used, you have to know it. I don't know it. Then you can't tell me if it's listed, because you have to know the process. You fill out a profile for hazardous waste. First question is, provide me the process, the name of the process that produces this. I don't know. Then you can't tell me if it's listed, because you have to understand the process to figure out if it's listed. I don't know the process. Then I can't tell you if it's listed or not. I've spent 8 minutes now on this question, and I've told you nothing, because I can't tell you. I can't tell you. All I know, and I don't know a lot, is it takes a big fish to hump a whale. I don't know. You with me? Okay. All right, let's go ahead. Okay, real world. That's life. Okay, so we talked about the P codes, the U codes, the F codes, the K codes. There's 194 acutely hazardous waste codes. There is a little over 500 U. If you look at the F and the K codes, they're a lot finite in scale. They're very specific to industries or very specific to chemicals. So it's not a big listing, but they're there. They're there. We're good? Any other questions? Okay, question. Yep. Nope. Ask away. The resin. I'm sorry? I add a resin that has a component A and component B. And what do we do? Okay, if I have a P-listed component, actual chemical that's in my resin, and I produce that waste, the resin. I take the resin, I get rid of it. Okay? Is the resin that I get rid of, that I wish to discard, did you mix component A with component B? No, I have no example. This is your example. Don't piggyback on my example. You mixed them. Oh, okay, so they're used, right? They're used? Oh, okay. So you have taken component A and component B, and you mix them together. They're used, right? Okay, so you're asking me, has it been used or not been used? Really? It's been used. It cannot be a P-listed waste. I have component A and component B. I decided to get rid of it, didn't mix them together, and the active constituent in the component B is on the U list, and I didn't do anything with it. I bought it, I'm going to use it, I didn't use it. Now I've got it, I'm going to get rid of it. That's not been used, that's not spent, that is federally U listed. It turns out, by the way, component A is not a hazardous waste. Not only is it not listed, it doesn't exhibit a hazardous waste characteristic, which we have not yet talked about. But it doesn't, that's non-hazardous waste. Or it's really reactive. It produces a lot of heat when you mix it with water. That's a hazardous waste also. They're both hazardous waste. But that's a California hazardous waste, and it's a federal waste. And the component B is a listed waste because it's U listed. Is that we good? Okay. I still didn't answer your question, did I? Okay, here we go. Ready? Presumptive list. I've already covered it, so I'm not going to kick a dead horse here, but you have common names of wastes, and they're broad. They're very broad. We think that this is generally a hazardous waste. It's broad categories. Laboratory wastes, spent solvents, toilet chemical cleaning wastes, my favorite. Broad, there's 90 categories. And if your waste comes from something that could be construed as coming from that broad category, California says, yeah, there's a chance it's hazardous waste. Maybe it's not, maybe it is. If you test it and it's not, it's not. If you test it and it is, then it is. Doesn't mean anything. It's kind of like a caution flag. Careful, be careful. We think these are, be careful, be careful. That's it. All right, here we go. This is the balance of your class. This is it. We're done with this, we're done. There is 4 characteristics, and there's a lot of subcomponents to these. But there are 4 general characteristics that make a waste hazardous. And they are ignitable, corrosive, reactive, toxic. And I'm going to take them in that order. 2 of them are the same. Go figure this out, Pat. No, check this out. You sit in the front row and you get up. You couldn't sit in the back row. You have to sit in the front. And then during, yeah, go figure, yeah. All right, so ignitability. So the federal definition of an ignitable waste federally is exactly to the California definition of an ignitable waste. And since I'm kind of already sharing that with you, there's one other one. The federal definition of an ignitable, a reactive waste is the same definition that California has for reactive waste. So if I've got a waste that's ignitable or reactive, it's both, state and federal. They're the same. Those two definitions are the same definition. The differences are, if I've got a waste that is considered to be corrosive or toxic, there are some differences for corrosive. California's definition is broader in scope. It captures more things. The biggest difference, and it's a big difference, is toxic. California has a much broader definition, and that's the significant difference that exists between the two. And what I'm about to do is define those four, state and federal, and dissect it, put it back together, give you some examples, and then we're done for the morning. We're good? So I've set the table. Okay, here we go. All right, so for the first one that's listed is ignitable. A waste is considered to be ignitable if I take my waste and I test the free liquid, i.e. it's a liquid, and I use a Pinsky-Martin's closed cup test methodology, give it to a lab, and they determine that the flash point of the liquid is at or below 60 degrees Celsius, which is 140 degrees Fahrenheit. And if it's at or below that threshold, and I decide to discard it, that is a federal and a state hazardous waste. What's a free liquid? What's a liquid? What's a liquid? I got a sludge. I have this kind of greasy matrix that's sludgy. So it's not a liquid and it's not a solid, it's a sludge. Okay, this is a real world, this is a real world scenario that I can give you. Okay, it's a sludge. So the test method says it's got to be a free liquid. So what's a free liquid? Oh, that's it. If I read Appendix 10 and look at SW 846, it says, yeah, you know what a free liquid is. It's when I use a 70 micron mesh screen used in the paint filter industry, and I put a 5 cc sample of my waste in it at 1 atmosphere at 78 degrees Fahrenheit, and you wait 5 minutes. And if there's a drip that comes out at the bottom, that is considered a free liquid. And if it doesn't drip within 5 minutes, your sludge does not have a free liquid, nor could it be ignitable based on this criteria, because this criteria is based on a free liquid. Is everyone with me? Okay. That's one of them. The other is, hey, it may not be a liquid at all. It could be a solid. And and through friction, it could actually cause the material to ignite. And if it ignites, it burns spontaneously and persistently, and it actually propagates. So it doesn't have to be a liquid, it could be a solid. I just described red phosphorus. Red phosphorus is what they put on the striker plates for safety matches and flares. And if I put friction against it and it ignites, that solid is an ignitable waste. Both state and federal, both. Not a liquid, but it's ignitable. Or absorption of moisture, calcium carbide. Calcium carbide is a flammable solid that's dangerous when wet. It's hygroscopic. It sucks the moisture out of the air. And when it does that, it forms a settling gas. And if it's ever ignited, it actually burns very persistently and aggressively. Now that solid is a flammable solid dangerous when wet. So if you have a DOT hazard class that's 4.1 or 4.2 or 4.3, and you go to get rid of it, that's probably an ignitable waste. Even though it's not a liquid, it's ignitable. Or it may be a compressed gas that's ignitable. So now it's not a liquid, it's a gas. And you go to get rid of it. That makes it a hazardous waste. Or if DOT, and we're a pirate agency, so we pirate the definition of a oxidizer. But if I've got ammonium nitrate and I go to get rid of it, and DOT says, oh yeah, by the way, ammonium nitrate is a 5.1 hazard class, it's an oxidizer. That means that it provides oxygen when it reacts chemically with other chemicals. And you go to get rid of it, that's not a solid or a gas, or it's not a cylinder, and it's not a flammable solid, it's an oxidizer. So when you dispose of it, that makes it a hazardous waste. No, I'm just, did you use the facilities? Are you lying? Now, the first one was an integrity question after you answered the question. Here's another one. Are you lying? You're getting older. Okay. And you couldn't do that 20 minutes ago when we started, right? Well, so in 20 more minutes, well, then stop drinking the coffee. I don't know. All right. We're good? That's it. That's ignitable. That's one of 4 characteristics. It's one of 4. It's one of 4. None of those 4. Oh, okay. It still may be a hazardous waste, but it's not ignitable. And if it's any of the 4, it's both state and federal. We're good? We're good. Pretty simple. Simple? Okay, all right. Corrosive. Okay, this one's a little different between state and federal. State. Now let's go federal first. Go RCRA. Does the material that's aqueous means the material contains free liquids, which is water. Okay, aqueous. I have an aqueous material and the pH is at or below 2, or acid. It's at or above 12.5. I'm going to call that an alkaline or a base. So is it at the low end of the pH scale or is it the high end of the pH scale? I'm going to consider those aqueous materials that now I'm disposing of as a waste a hazardous waste because it exhibits a corrosive characteristic. It'll probably cause problems to tissue irreversibly. Now, it may be that the pH is above 2, or it's maybe below 12.5, but if I applied a regular application to mild steel, it would dissolve 6.35 millimeters, which is a 1/4 inch, through mild steel over the course of a year. And so independent of pH, it attacks mild steel. And that's at 6.35 millimeters, which is a 1/4 inch. It'll dissolve a 1/4 inch of mild steel in a year. Well, I only have 90 days to keep my waste. I got to get rid of it. I don't have a year to figure it out. So the test methodology in SW846, they have a thin sheet of mica, metallic material, and they see if it starts to pit. And they check that after 96 hours. If it starts to pit, then yeah, probably it is. But people don't do that, so I just wasted 30 seconds of your life. Right? So it's mostly pH, aqueous, liquids, with water, pH, liquids, aqueous, federal. Has everybody got me? We're okay? Okay. California, same definition. And then they say, hey, I got an idea. This is California. Hey, my waste is not aqueous. It's a liquid, and it doesn't contain water. That's not aqueous. Aqueous, federal, it's got to have water. In California, it could be a non-aqueous liquid, and then you have to add water at equal proportions and then test the waste. Or it may be a solid. California says, hey, I got an idea. If it's sodium hydroxide, red devil eye, crystal Drano, you go get rid of it, that has no water. Take an equal portion by weight, add it to water, dissolve it, and once you dissolve it, if in fact the pH is at or below 2 or at or above 12.5, that's a hazardous waste in California. I'm going to say the same thing differently. Here we go. Federally, has to have water pH. California has to have water, doesn't have to have water. It can be a liquid or it can be a solid. And when you add water, pH. I'll say the same thing a third way. The federal definition of a corrosive waste is focused on liquids that are aqueous, pH, corrosion to metal. California says it's much broader. We're going to capture those things as well as those things that are liquids that don't have water, as well as solids that don't have water, and you add water and test. So the California definition is a lot broader in scope, People call that being more restrictive. Well, actually it's broader in scope. It captures a lot of things that are not captured federally under RCRA. We good? Fundamental difference. Right? Right? Okay, reactive. This is the last one that's the same. So if I've got a waste that's considered to be unstable, undergoes violent changes without detonation, that's considered a reactive waste. Unstable. A lot of organic peroxides are unstable. They're kept refrigerated. They're shipped, stored, refrigerated. If they reach room temperature, they'll reach what's called an auto-ignition temperature. Few select industries have those, but that's an organic peroxide. Reacts violently with water. Lithium, sodium, potassium, franconium, cesium. These are water-reactive chemicals. Put them in water, they get hot. That reacts violently with water. That is a reactive waste. Same definition state as federal. No difference. Forms explosive mixtures with water. That's calcium carbide. Add water to calcium carbide, it makes acetylene gas. Very explosive. Generates toxic gases, vapors, or fumes if you produce them or introduce water with them. That could be a lot of stuff, right? Cyanide or sulfide-bearing materials that when you expose them to a material where the pH is above 2 or less than 12.5, it establishes and produces an environment that is a toxic gas. What's the definition of a toxic gas? Yeah, probably REL, PEL. That's a toxic gas. It's been determined that it's toxic at that concentration. So, and this is for cyanide and sulfide-bearing compounds. Capable of detonation or explosive reaction. Okay, that could be white phosphorus. White phosphorus is pyrophoric. It reacts if it's exposed to air. It'll just ignite. Readily capable of detonation or explosive decomposition, blah, 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 and forbidden explosives that are defined by the U.S. Department of Transportation. Subjective. Subjective. Some of these have case histories that kind of define that. Like for cyanide and sulfide, is it above the PEL? Case history. It's explained. But some of these generates toxic gases, vapors, or fumes. Oh, okay, well that's kind of a PEL thing. Reacts violently with water, reacts violently with water. What if something explodes in water, pretty violent. If I put it in water, it bubbles. Is that violent? How about if it bubbles vigorously? Is that violent? How about if the temperature differential in the water is more than 40 degrees? Is that violent? 80 degrees. Is that violent? Do you see where I'm going with this? Not defined. Little bit of subjectivity. This definition, gray. Gray. It's black and white. There you have it. Black, white. There you go. That's it. But it's gray. How it's applied, how it may be construed, how it's been construed historically. Right? We're one characteristic away from being done with the class. It just happens to be the big nut. It's the elephant in the room. And that happens to be toxicity. So the federal government, in their infinite wisdom in '74, drafted proposed legislation, looked at it in '75, passed it in '76, and when they passed RCRA, they said, we have solved the Monte Grail. We have decided for 40 chemicals, if they're in a material matrix, liquid solid sludges, above a certain threshold, that makes this material that you decide to get rid of and dispose of hazardous waste. 40 chemicals. This list is so finite, it's really small. Okay? Number one. Number two, that list uses a test procedure to determine whether it's toxic or not toxic. For example, I have dirt. The Desmond says, Jerry, I got this dirt. It's got pentachlorophenol in my dirt. And I've established what makes it toxic. So if I want to figure out if it's a federal T-clip waste that has a regulatory threshold, I send it to a lab, and what they do is they try to simulate the conditions that exist in a landfill. So they're going to dilute it, and they're going to see the possibility of how much of that's going to migrate. So what they're going to do is they're going to take my dirt, and they're going to digest it for 24 hours using acetic acid, vinegar, and then they're going to dilute it 20 to 1, because that's what happens when you put stuff in dirt. It doesn't all move. Some of it ends up binding with other types of chemicals and substrates in the dirt. They call that chelation. So when a material, typically a metal, moves through the dirt, if it's a positive or negative charged ion, it'll find something that it's attracted to, and it just sits there. It doesn't move anymore. And so they call that chelation. So we're going to simulate this for everything. And so that procedure that I just described is called the Federal Toxicity Characteristic Leachate Procedure. What I want to point out here is that when you look at T-clip federally under RCRA, it's not how much of that chemical is in the dirt. It's how much of that chemical is in the dirt after you dilute it and you digest it and you dissolve it, and then you... So the T-clip is a test method that looks at how much of that chemical ends up in the dirt after it's subjected and applied to a specific methodology. All right, so that's T-clip. That's T-clip. We good? There's 8 metals, 32 organics. There's 8 federal RCRA metals. There's 32 organics. We have a list of 40 chemicals. My chemical, my PCE used in dry cleaning, it's not on the list. Oh, okay. Well, then that's not a characteristic waste that's considered toxic, because for it to be considered a characteristic waste toxic under RCRA, it's got to be one of the 40 chemicals. It's not one of the 40 chemicals. It may be a listed waste. It may be P or U or F or K, or that waste is not a hazardous waste federally, because for it to be a toxic waste under RCRA, it's got to be one of the 40 chemicals. Well, it's not one of the 40 chemicals. It's not going to be a RCRA toxic waste. It may be a California toxic waste. We're going to talk about that here in about a minute. But it's not a federal toxic waste. To be federally toxic has to be one of the 40. We're good? Okay. All right. This is the elephant in the room. This is the one that captures all of us. Okay. So I have, the state of California says, I like that. I like that idea. Yeah. So what we're going to do is we're going to come up with some lists, and we're going to figure out if a chemical that we consider toxic is in your waste stream. And so we did that. And we have a list in California that involves 37 chemicals. It's 17 metals and asbestos. We call that inorganics. And there's a list of 18 organic chemicals. And what we'll do is we'll figure out if your waste has any one of these 37 chemicals in California and it's above a certain amount, that makes it a hazardous waste. All of the federal metals is on the California list. So California regulates 9 more metals. Let me say it differently. In our infinite wisdom, we have established a list of about 70 chemicals combined. And if you have one of those 70 chemicals in your waste and you go to get rid of it, I can tell you hazardous waste or not. You know what I'm actually telling you, but I'm not telling you? That list is finite, and the amount of chemicals we use is huge. So most chemicals aren't on the toxic criteria, so I can't tell you if it makes the waste toxic based on its concentration. But if it's one of those 37 chemicals in California, I can do it. And when we talk about the waste extraction test, once again, it's 2 tests. How much of that chemical is in the waste? Is it at or above that concentration? It's a hazardous waste in California. Federally, it's a dilution process. So California says, I kind of like that idea. So we're going to have a similar test method to the federal criteria. But in California, if you've got lead in your dirt, when you send that sample to a lab, what they're going to do is they're going to say, well, yeah, let's figure out how much of the lead's going to move out of the dirt. So let's dissolve it, and they're going to use citric acid. The federal government uses acetic acid. So it's similar, not the same. And then California says, yeah, let's digest it. Let's see how much dissolves in 2 days. So we dissolve it in 48 hours. The federal government says, yeah, let's give it a day. Similar, not the same. And then the state says, when we're done, what we've dissolved in 2 days using citric acid, let's dilute it 10 to 1. And the federal government says, yeah, that'll work, except for they're going to dilute it 20 to 1. So the federal T-clip is very similar, not the same, as the California STLC. They're similar, not the same. So when I send my sample of lead, dirt, asking for them to test for lead to a laboratory, I need to tell them, hey, test it federal under T-clip or test it state under STLC. Very similar, not the same. It turns out that when you look at the concentration of lead in dirt under the federal T-clip, it says 5 milligrams per liter. If you look under the state criteria, it says, here we go, 5 milligrams per liter. It's the same threshold. It's the same concentration. Not the same test method. So the question comes up, which one's more aggressive? And the one that's more aggressive, 999 times out of 1,000 is the state criteria. You dilute it longer, you dissolve it longer, you digest it longer, you use a little more aggressive acid, and you only dilute it 10 to 1. Federally, you don't digest it as long, and you dilute it 20 to 1. So if you look at the criteria, federal state, the state STLC, which is similar to the federal T-clip, for all the metals, they have the same threshold listed. But when you go to analyze a waste based on those concentrations of those chemical constituents, inorganics, that's in my waste stream, the methodologies are very different. And California is going to capture things long before they would get captured federally. So we're likely to capture it, and it's still not considered a RCRA waste because it's not a hazardous waste federally. But if it is, then how I manage it, label it, mark it, dispose of it, and have it treated when you send it off for disposal is driven by the federal standards. So I've got to be certain when I classify my waste if it's state or federal or both. And if it's both, that's federal. If it's state, that's state. And if it's federal, for a metal, it's probably going to be state as well. But you manage it as a federal RCRA hazardous waste. Question? Okay, all right. If I analyze my waste and it fails the state STLC for lead, should I manage it as a RCRA TCLEP hazardous waste? That's the question. And it depends. It depends on if it's above or below the federal TCLEP. So the state says, I kind of like this idea. Now, this doesn't make any sense to me. I understand the theory behind it. You know what makes sense to me? Check this out. How much lead is in the dirt? That makes a lot of sense to me. Doesn't it? Okay. So the state says, you know what? Let's develop a threshold for lead. And they did. They came up with and said, hey, you know, 500 milligrams per kilogram. If you've got 500 parts per million of lead, or maybe it's 2,500, that makes it a hazardous waste. We don't care how much is soluble or not. We don't care. That's called the total. That's the other half of the state wet test. That total. How much do you have? How much total is in the dirt? And if it's above that, then that's a hazardous waste. I don't have to do state or federal. That's a hazardous waste in California. California. But when you run the total, when you digest it for lead, when you digest lead, that lead is completely digested. They don't care if it's soluble, non-soluble. They don't care if it's going to move. They digest it using nitric acid. If there's lead in the dirt, it's coming out. And they're going to figure out how much is there. Okay, that makes sense. How much lead's in the dirt? That makes sense to me. So when I'm trying to analyze my waste and I'm trying to figure out state, federal, state, what you're asked to do is to run the total first. So I don't know state or federal, run the TTLC value first. Run it. Because for it to be a RCRA waste, and I'm talking about dirt, I'm talking about lead, for it to be a RCRA waste, that the lead concentration that you run, when you run the total, has to be at least 20 times above the TCLEP to be a candidate for being a hazardous waste federally. I'm going to say it differently. If I want to figure out if my dirt with lead's a hazardous waste federally, I'm going to run the total. The concentration comes back 0.002 milligrams per kilogram. Okay? I'm done. Because it can't be a state or federal. It's so far below. And then, if you divide that concentration by 10 compared to the state, if you divide that concentration by 20, then you compare it to the federal. So if you want to figure out, I'm explaining something to you that will take me about 15 more minutes, and it might work. I might be successful. But if you talk to your lab manager, when they run metals, when they do a CAM 17 metal exam on a solid, they've already got this dialed in and figured out. What they're going to do is they're going to run a total. And then they're going to give you an asterisk next to chemicals that says, hey, warning, you might have a problem with this concentration. Because they know that when you run the federal TCLEP, when you digest it, you're only digesting the soluble matrix of the lead out of the dirt. Not all the lead dissolves when you run TCLEP. Only the soluble lead dissolves. And then whatever dissolves, that's diluted 20 to 1. So when you run the total, the concentration you get for the total would have to be at least 20 times above the magnitude of the TCLEP to possibly fail the TCLEP. What time is it? Okay, I got 15 more minutes. Okay, all right. So I'm going to make sense out of this. Check this out. The federal TCLEP, finite, 40 chemicals, and it's above or below the threshold, it's regulated. California, Under the wet test, 2 criteria. It's more aggressive than the federal. All the federal metals is on the California list, and they have the same regulatory threshold. But the methodology that's used for testing is not the same. So if something's a California waste, it doesn't make it a federal waste. If something's a federal waste because of a metal, it is a California waste. It is. Okay, last concept, then I'll leave it. If I've got a liquid, not a solid, not dirt, it's a liquid. When you run the total amount of that metal in my liquid, that metal is dissolved in my liquid. And when I test for that metal in my liquid, that's the total. And that's the soluble. And that's the T-clip. And that's the STLC. And that's the TTLC. And I compare that to all 3 values. There is no dilution that occurs with liquids. Liquids can immediately leave an environment and affect the environment. And they can leave an area and they're very mobile. So if I have a liquid and I test it for metal, there is no dilution at the state or federal level. If it's a liquid and it's got a metal, the liquid, when it's tested for lead, the concentration of lead, I compare that against all 3. That's the T-clip, that's the wet test, that's the total. Liquids are not dissolved. Liquids are not diluted. Liquids, when you test for the metal, that is compared against all 3 standards. Because it's a greater environmental concern because it may move. If it's a solid, it's not likely to move very much. So we dilute it. Liquids, they move. Is that clear as mud? How many people are dialed into what I just said? 3, 4. All right, we're good? Good. I apologize. It's simple. All right. Then California says, okay, I got an idea. Hey, if you know the oral LD50 if you eat it, or if you know the inhalation LC50 if you breathe it, or if you know the dermal LD50 if you rub it on your skin, and you buy a chemical that's been calculated at a NIOSH-approved lab for about $12,000, then I can tell you, and you can tell me, if it's a hazardous waste. So if I've had that tested for my materials, and I go to dispose of it, I would know, you would know, and I can tell you if it's a hazardous waste. Footnote. That doesn't work, and I'll tell you why. Most wastes that are produced in California and throughout the United States, they're a witch's brew. They're chemical A with chemical B with some chemical C and chemical D, and it's a witch's brew. We do not know what the actual resultant LD and LC50 values are. Number 1. Number 2, it's expensive. Number 3, it takes 9 months. I got 90 days to get rid of this stuff. I don't have 9 months. And it's a lot of money, $50,000, $60,000, $80,000 to test for this. What I'm telling you is, I've elected to waste 1 minute of your life explaining something that's probably off the radar. We good? We good? Okay, all right. Aquatic acute 96-hour fish bioassay. This is the one that is kind of a catch basin in California. This is by far the fundamental difference state-federal. It goes like this. Got an idea. If I've got stickleback fish, fathead minnows, rainbow trout, and I put them in a tank, and I take an extract of your waste and I put it in the fish tank, it will kill the fish. And so California took a chapter out of the POTW permit conditions issued by the POTW under the Clean Water Act, and there's a fish bioassay test for tertiary treatment facilities before they dump their materials effluent after treatment into the Pacific Ocean. California says you know, if a sewer treatment facility's got to test their waste, see if it's toxic, we like that. So they said, we'll do it. Doesn't exist federally as a hazardous waste. RCRA doesn't have the equivalent. So what California said was, yeah, got an idea. Let's take 500 milligrams of your waste per liter of water. So it's a portion, about 1/12. And let's put it in a fish tank, and let's stick in 10 fish. And if those 10 fish survive, then your waste, which we took a sample of, is not a hazardous waste because it wasn't toxic to the fish. If 5 or more of those fish do not survive after 96 hours, then your waste that you produce, that I took a sample of, that killed the fish, that in California is a non-RCRA hazardous waste based on toxicity. And it's the 96-hour aquatic fish bioassay. Now, if 4 fish die, not toxic. 6 fish die, toxic. 5 fish die, toxic. 5 fish floating upside down, one of them, the gills are moving, not toxic. Real close. So what the state says is we'll develop a methodology, we'll figure out a definitive test. So what they do is they say, hey, got an idea. Take the waste, and what we'll do is we'll take and we'll dilute it a little bit. So we'll take a test methodology in a tank that's 250 milligrams per liter, half the regulatory level. We'll have one at the regulatory level, and then we'll concentrate that by 50%, and we'll have another tank at 750 milligrams per liter. So one's a little bit below, one's a little bit above, and one's right on the money. And that's the one that counts. And we'll test this test, we'll run it for tanks. And what they do is they run a control tank. Because maybe the fish died because over the weekend it got cold and the fish died. Well, if the fish died in the control tank, we got to start all over again because all the fish died everywhere, had nothing to do with the waste that you put in it. So if I run a definitive test, about $800, takes about a week and a half, 2 weeks. They're running 80 fish because they duplicate the tanks. 2 controls, 2 dilute, 2 at, 2 above. It's a definitive test. That's called the definitive fish bioassay. But that one test is what captures a lot of waste in California that are not presumptive, that are not listed, that are not identified. But if my waste that I produce at my facility kills the fish in 96 hours, then by default, when I go to dispose of, discard that waste, that is a California regulated, non-RCRA hazardous waste in the state of California. And that's truly the biggest fundamental difference that exists in California, and there is no equivalent of that exists federally. Going back to the federal criteria, it's one of 40 chemicals. And if it's not one of those 40, it's not toxic federally under RCRA. That is. The last happens to be a list of carcinogens. If I have a carcinogenic compound and there's a list of 16 of them in Title 22, if one of those carcinogenic compounds is included in my waste at or above 10 parts per million, how much is that? That's 0.001%. Then that material that has that carcinogen at or above 10 parts per million, I go to get rid of it, and it's very select for certain industries, then that's a hazardous waste based on toxicity. Don't need to test it unless I know if it's above or below 10%, 10 parts per million. And that is what makes a waste toxic in California. Where are we at time-wise? I have 4 minutes. Check this out. Ready? You got any questions? Any questions? Do they have to use fish? They have to use one of 3 species specified under SW 846. And those 3 species are fathead minnow, rainbow trout, stickleback. We're done. We're done. We can turn them loose, we can grind them up, we can eat them, but we can't use them again. Can't be reused. Yeah, except for the ones for the standard, the control. Question? Yes. No, you can do a presumptive, which is just 500 milligrams and the control. That's it. You don't have to do a little bit below and above. The definitive is that I have my presumptive test and it kills 4 fish. It kills 4 fish. Not a hazardous waste. You can't tell me how close I am unless I do a definitive. And I'll go back to what I said earlier. You don't have to do any of it. It's just if you make the wrong decision, now you may be liable for a bad decision. Yeah. Okay, I got probably 2 minutes left. Okay, hey, listen, enjoy your conference. It was a pleasure. It was an honor to be here to answer everybody's questions, except for yours. I didn't answer yours. All right, listen, enjoy yourself. Listen.